So question 3, given that we have points at A at 1, -1, B at 3, -1, C at 1, -6, they form triangle ABC, and D at 4, 1, E at 2, 1, and F at 4, 6, form triangle DEF. Prove that triangle ABC is congruent to triangle DEF. Read the following proof for this problem carefully and then follow the instructions. So use the blank to find the distance of AB, the distance of BC, the distance of AC, the distance of DE, the distance of EF, and the distance of DF. So I'm looking at this and seeing how it's read. This is read as the distance from A to B, so we're going to be using a distance formula to find those distances since it is not given. Show that AB equals blank, which equals blank, and BC equals blank, which equals blank, and AC equals blank, which equals blank. Okay, those are a lot of blanks through that, so I guess we'll figure out what's going on there. Use the definition of blank to show that each pair of congruent lengths represents a pair of blank segments. Use the blank to state that triangle ABC is congruent to triangle DEF. So since it's going off of all of the side lengths, and that is for blank 10, all of the side lengths means that they're going to be using side congruence postulate. So that's just something that I picked up, is noticing that they are comparing all of the side lengths for all of the triangles. So it's also talking about congruent lengths represent a pair of congruent segments. So blank 8 and blank 9, let's see the options, EF 5, segment of DE, side angle side congruence, distance formula congruence, perpendicular segments, or congruent. Okay, so I'm going to think of congruent and segments. So use the definition of congruent to show that each pair of congruent lengths represents a pair of congruent segments. Well, pair of congruent segments sounds correct, so blank 9 is congruent. So we have congruent, and use the definition of congruence to show that each pair of congruent lengths represent a pair of congruent segments. So we are going to be using congruence. Where did it go? Congruence. Blank 2, 3, 4, 5, 6, and 7. Now our options are going to be numbers and the corresponding segment length. So we have to know which segments are going to be corresponding to which segments, and this is how I know. So they're listing it off as triangle ABC. This is listing it off as triangle DEF. So triangle ABC and triangle DEF. Actually, let me do this just to show you what I'm talking about. Okay, just because A starts here, it does not mean that it is corresponding to whichever label is listed in that position right there. Because A is the first label in this triangle, it's going to correspond to the first label or the first point in the next triangle. So A actually corresponds to point D. Point B corresponds to point E. And point C corresponds to point F. So C and F correspond with each other. So corresponding side lengths are going to go between corresponding points. So A to B, that side length, is going to be corresponding to the side length that goes from D to E, because those are its corresponding points. Side length B to C is going to be corresponding from side length E to F, because those are its corresponding points. And side length C to A is going to be corresponding to side length D to F. So it's based on how it's listed, so that we know. And now it's asking us to show that the distance of AB. So first let's find the distance of AB. This is how I would do it. I would again pull up GeoGebra, and I would start new, and I would just start by doing my points. A is at 1, -1, B, and I want the names. B is at 3, -1, and C is located at 1, -6. And that is a triangle, so select your segments and open them up. So there's one triangle. Now we have another triangle, D, F, and D, E, F. So we have 4, 1, and 2, 1, and 4, 6. So let's do the segments again. And now I'm just going to find the distances of them. So again, it's this angle. There's the distance, F to D, D to E, E to F, A to B, B to C, C to A. So that's how I would use this tool in order to help me find the distance. So side length AB is equal to 2. So blank 2 is going to be 2, which equals the same distance as DE. So blank 3 is going to be the distance for DE. And make sure it's distance, not segment. So that represents distance. So blank 4 is BC is equal to what? So BC is equal to 5.39. So I'm looking for 5.39. I do not see it. I do see the square root of 73 and the square root of 29. So this is what I'd do. Pull out a calculator, type in the square root of 29. That's 5.385, which would round to 5.39, since this 5 would round that 8 up to a 9. So that is the square root of 29. So we have the square root of 29. That's how I would use this tool. And that is equal to the distance of EF. So blank 5 is going to be the distance of EF. Make sure it does not have that segment above it, or it's talking about the segment, not the distance. And that does matter in math. So then AC is equal to 5. So blank 6 is 5, and blank 7 is going to be the distance of DF. So DF. So then it says use the definition of blank congruence to show that each pair of congruent lengths represents a pair of congruent segments, which is what we had. And by side, 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 we matched corresponding sides. BC is congruent to EF. AB is congruent to DE, which is a corresponding side, and CA is corresponding side is FD, and they are the same length. So that's how I would use my tools to answer this question. I hope that helps.